Hello everyone. Today we will learn about propagation over water and flat open area. In previous class, we had already discussed about land to mobile propagation over water when mobile unit is moving. This is the first case. And now today's class, we will learn about the second case. That is propagation between two fixed stations. Propagation between two fixed stations over the water or flat open land. So here I am considering two fixed stations. This is one station and the other is the second station. The first station above the hill that is above the height distance h1 is a fixed antenna. Small h1 is placed. And on the right side, here also on flat area above the land surface at a height of capital H2, an antenna of small h2 is placed at the height of small h2. So here we will find out the propagation of wave between these two fixed stations over the water or flat open land. Let us consider this over the water or flat open land. So here the received power PR is equal to is given as PR is equal to PT into 1 by 4 pi d by lambda whole square modulus of 1 plus AV e power j 5V and e power j del phi modulus square. If I consider this antenna propagation between the two fixed stations over the water, then I got the expression PR is equal to PT into 1 by 4 pi d by lambda whole square 1 plus AV e power j 5V exponential of j 5 j del phi. Hello everyone. Today we will learn about propagation propagation of wave between two fixed stations. Propagation of wave between two fixed stations. In the last class, we had discussed the propagation of wave land to mobile propagation over water when mobile unit is moving. This we had studied in the last class. So this is the first case. The first case in propagation over the water and flat open area. And now the second case is hello everyone. Today we will discuss about propagation over water and flat open area. In last class, we had studied the first case, that is land to mobile propagation over the water when the mobile unit is moving. This is the first case we had learned in the previous class. Now today's class, we will learn about propagation between two fixed stations. It is propagation of wave between two fixed stations. So in this condition, in this case, I had taken two fixed antennas. That is, one antenna H1 is placed above the hill. That is at a height of H1, capital H1, height of the hill, capital H1, and above the hill, an antenna of height small h1 is placed. And on the other side, above the flat area, above above some land area at a height of h2, or consider a hill h2, an antenna of small h2 is placed. Now we will study the propagation of wave between these two fixed stations, that is h1 and h2. And here we can observe that there is a direct wave from h1 and h2, and there is also a reflected wave from h1 and h2. So from this diagram, we will write an equation, that is received power PR is equal to PT into 1 by 4 pi d by lambda whole square modulus of 1 plus AV e power j 5V and e power j del phi. modulus square. This is the same, this is the expression. In this expression, pt is the transmitted power, d is the distance between two stations, lambda is the wavelength, and av, we know that reflection coefficient. The reflection coefficient is taken as -1 for mobile communication, we know that. So av is -1, and del phi is the phase difference between direct wave and reflected wave. So we are having here two waves, direct wave and a reflected wave. So the phase difference between these two waves is given by del phi, and phi v, phi suffix v is a phase of a complex reflection coefficient. So from this equation, I will substitute reflection coefficient AV is equal to -1. We know that the reflection coefficient AV is equal to -1 in mobile communication, and phi v is equal to phi suffix v is equal to 0, because when vertical indices is small and theta is small, then we will consider phi suffix v is equal to 0. Then after substituting this AV is equal to -1 and phi v is equal to 0, I will get the expression PR is equal to PT into 1 by 4 pi d by lambda whole square modulus of 1 minus cos del phi minus j sin del phi whole square. How I got this expression? See, if I substitute phi v here, phi suffix v 0, then it becomes e power 0. E power 0 is equal to 1. This becomes 1. And we know that reflection coefficient AV is equal to -1. So if I take AV is equal to -1, then I will get modulus of 1 minus e power j del phi modulus whole square. This is the expression I am getting here. This is the expression I am getting. This is the expression I am getting here. So this expression is same as the expression we had learned in two-ray model. Same expression we had learned in two-ray model. In two-ray model, what is the expression? See, I will show you the diagram, show you the topic. This is the two-ray model. In this two-ray model also, here we are taking one station, antenna as antenna station, and here mobile antenna. In these two stations, there is one direct wave and one reflected wave. For this, I had written the expression PR is equal to P naught into 1 by 4 pi d by lambda whole square modulus of 1 plus AV e power j del phi whole square. This is the same expression I am getting from between the two fixed stations. See, between the two fixed stations, after substituting AV is equal to -1 and phi suffix v is equal to 0, I got the expression 1 plus, I got the expression PR is equal to PT into 1 by 4 pi d by lambda whole square modulus of 1 minus e power j del phi whole square. And simplifying the above expression, same as how we had derived in two-ray model, taking e power j theta is equal to cos theta plus j sin theta and substituting the values, I will get PR is equal to PT into 1 by 4 pi d by lambda whole square modulus of 1 minus cos del phi minus j sin del phi whole square. And after simplifying this, I will get PR is equal to PT into 1 by 4 pi d by lambda whole square into 2 minus 2 cos del phi. This expression, if you observe the two-ray model or the topic we had discussed in phase difference between direct path and ground reflected path, there the calculations for this complete equations we had written there. So I am writing the direct equation for this PR value, direct equation. So the direct expression after deriving PR is equal to PT into 1 by 4 pi d by lambda whole square into modulus of 1 minus cos del phi minus j sin del phi. After simplifying this expression, I had got the value PR is equal to PT into 1 by 4 pi d by lambda whole square into 2 minus 2 cos del phi. Now I will take this PT into 1 by 4 pi d lambda whole square as P naught. I will consider. Then I will get the expression PR is equal to P naught into 2 minus 2 cos del phi. We know that del phi, here what is del phi? Del phi is phase difference between direct wave and reflected wave between the two fixed stations. So we know that del phi is equal to beta into delta D. Delta D is the difference between direct wave and reflected wave. As it represents phase difference. I will take the phase constant beta. So beta is the phase constant given by beta is equal to 2 pi by lambda, and delta d is the difference between reflected wave and directed wave. And after simplifying the expression delta d, that is d1 minus d2, direct wave, reflected wave, if I subtract both the values, I will get delta d is equal to 2h1 h2 dash by d after simplifying the expression. So how I will get then d1 and d2 values to subtract d1 and d2? So here I have the values of d1 and d2. This d1 and d2 I had written from this diagram. See, from this diagram, reflected direct wave and reflected wave. Here I will take the hypotenuse values and I will substitute adjacent and opposite values, square root of adjacent and opposite values. And you can also observe this diagram between the two stations with direct wave and reflected wave is same as the diagram in the two-ray model. And there also I will get the values. I will get the values d1 is equal to square root of h1 plus h2 whole square plus d square, and d2 is equal to h1 minus h2 whole square plus d square. But here I am substituting in place of h1 dash, and in place of h2 dash. So if I subtract d1 and d2, and I will get the delta d value as 2h1 dash h2 dash by d. And after substituting in del phi value, del phi is equal to beta into delta d, that is beta we know that 2 pi by lambda, and delta d is 2h1 h2 dash by d. So finally I will get the expression del phi is equal to 4 pi h1 dash h2 dash by lambda d. This is the expression I had got after calculating this diagram, the propagation between two fixed stations. And the expression I had got is received power is PR is equal to P naught into 2 minus 2 cos del phi. This is the final received power expression. And del phi is, and here cos del phi. Del phi value I had got, del phi is equal to 4 pi h1 dash h2 dash by lambda d. Okay, this is the expression. Now further I will take the expression PR expression, that is received power expression, is equal to P naught into 2 minus 2 cos del phi. The expression I had got after simplifying the expression I had got here, PR is equal to P naught into 2 minus 2 cos del phi. I am taking this expression. From this expression we apply 5 conditions. We will apply 5 conditions. Here I am taking PR is received power, PR is received power, and P naught is equal to received power in space. The received here first condition I am taking PR less than P naught, that is the received power is less than power received in free space. So I am giving P naught value. So for the first condition PR less than P naught, what is the del phi value I should take? So here I am taking del phi value as pi by 3. I am taking del phi is equal to pi by 3. Then if I take del phi is equal to pi by 3, substitute in this equation 2, substitute in 2 minus 2 cos del phi. If I substitute this del phi less than pi by 3 in 2 minus 2 cos del phi, then the expression I will get is less than 1. Here I am taking del phi is equal to pi by 3. Less than pi by 3. Pi by 3 means pi by 3 value is 60 degrees. So take less than 60 degrees. So for suppose I am taking del phi is equal to 30 degrees. If I take del phi is equal to 30 degrees and if I substitute in cos 30 degrees, then 2 minus 2 cos 30 degrees. What is the value of cos 30 degrees? Root 3 by 2. Then I will get 2 minus 2 into root 3 by 2. That is 2 minus 1.732, that is equal to 0.2, which is less than 1. So here from the above expression PR is equal to P naught into 2 minus 2 cos del phi, I got the value less than 1. PR is equal to this expression P naught into 2 minus 2 cos del phi, I got less than 1. So I had written the first condition as PR less than P naught when del phi less than pi by 3. When del phi less than pi by 3. And in the second case, I am taking PR is equal to P naught. PR is equal to this value, PR is equal to P naught. If PR is equal to P naught, then what will the value I will get here? PR is equal to 0. Sorry, I am taking the second condition as PR is equal to P naught. If PR is equal to 0, then I should get 2 minus 2 cos del phi as 0. When I will get 2 minus 2 cos del phi is equal to 0? When del phi is equal to pi by 2 or 0. When del phi is equal to 0 or 2 pi, not pi by 2. When del phi is equal to 0 or 2 pi. If I take 0, del phi value, then apply here. Then cos 0 is equal to, we know that cos 0 is equal to 1. Then 2 minus 2 into 1, 2. So 2 minus 2, 0. So 0 into P naught. Substitute here. 0 into P naught, 0. So PR is equal to 0. So PR is equal to, we get PR is equal to 0 condition when del phi is equal to 0 or 2 pi. Next, third condition, I will take PR is equal to P naught. PR is equal to P naught when then 2 minus 2 cos del phi is equal to 1. 2 minus 2 cos del phi is equal to 1. Then what is del phi value? The del phi value is equal to plus or minus pi by 3. What is pi by 3? Pi by 3 is equal to 60 degrees. Then apply cos 60. Del phi value 60 degrees. Then cos 60. What is the value of cos 60? 1 by 2. So substitute here. 2 minus 2 into 1 by 2. So I will get 1. So 2 minus 1, 1. So 1 into, substitute here. So 1 into P naught, P naught. So PR is equal to P naught is the condition we had got when del phi is equal to plus or minus pi by 3. And the next condition, PR greater than P naught. PR greater than P naught is the condition we had obtained when 2 minus 2 cos del phi greater than 1. So when I will get 2 minus 2 cos del phi greater than 1? When del phi is between pi by 3 and 5 pi by 3. Here pi by 3 represents 60 degrees. 5 pi by 3 represents 300 degrees. So between this 60 degrees and 300 degrees, I am taking as 90 degrees. I will take the 90 degrees value. Then apply here. Cos 90. What is the value of cos 90? 0. So 2 minus 0, 0. So I am getting 2. So substitute here. If I substitute here, then I will get PR is equal to P naught into 2. That is P naught into 2, which is greater than 1. So here PR is the greater than P naught is the condition applied. Next condition, PR is equal to 4 P naught. PR is equal to 4 P naught. So I will get 4 P naught when 2 minus 2 cos del phi is equal to maximum value. When I will get maximum value? When del phi is equal to 180 degrees. So apply del phi is equal to 180 degrees. So del phi 180. So substitute here. So cos 180. What is the value of cos 180? Minus 1. So 2 minus of 2 minus 1. So what I will get? 2 plus 2, 4. So I am getting the 4. So substitute this 4. 2 minus 2 cos del phi value here 4. So PR is equal to 4 times of P naught. So I am getting the condition PR is equal to 4 P naught when del phi is equal to 180 degrees. So these are the del phi values. So depending upon the received power PR and transmitted power, we can get phase difference del phi values and its conditions represent different phase values at different conditions. Clear? This is about propagation between two fixed stations. Okay, thank you.